Open data is data that can be freely used, reused, and redistributed by anyone or subject only, at most, to the requirement to attribute and share alike. In other words, without any restrictions, open means anyone can freely access, use, modify, and share data for any purpose. The data must be available as a whole, and at no more than a reasonable reproduction cost, preferably by downloading over the internet. The data must also be available in a convenient and modifiable form. The data must be provided under terms that permit reuse and redistribution, including the intermixing with other datasets. The data must be machine-readable. Everyone must be able to use, reuse, and redistribute. There should be no discrimination against fields of endeavor against persons or groups. For example, non-commercial restrictions that would prevent commercial use or restrictions of use for certain purposes are not allowed. The concept of fair originated from a 2014 workshop in Leiden, Netherlands, titled Jointly Designing a Data Fair Port. The workshop aimed to boost knowledge creation and sharing, involving researchers, librarians, archivists, publishers, and funders. Participants discussed and developed the FAIR initiative, focusing on principles for easier data discovery, access, integration, and reuse. These discussions led to the FAIR Guiding Principles, which Force 11 drafted in 2015. FAIR Principles were officially published in 2016 in a scientific data article, gaining significant global attention. The Association of European Research Libraries now recommends the FAIR Principles for data management. FAIR stands for findable, accessible, interoperable, and reusable, providing a robust framework for data sharing. The FAIR principles gained considerable attention because they don't just focus in making research data human-readable but also machine-readable. This becomes especially significant when considering the future implications of data mining or harvesting. Therefore, data that meet these principles is FAIR data. Metadata and data should be easy to find for both humans and computers. Machine-readable metadata are essential for automatic discovery of datasets. Therefore, by assigning persistent identifiers and providing rich metadata where the dataset identifier is included in metadata record describing the data, data can be located and accessed quickly by researchers and machines, enhancing its discoverability and usability, and facilitate data citation. Once the user finds the required data, she or he needs to know how they can be accessed. Is the dataset archived in long-term storage, repository, and made available? This does not imply that the data have to be openly available for everyone, but information on how the data could be retrieved or accessed, or not, has to be available. Therefore, clear access protocols, permissions, and standards enable users to retrieve and obtain data. Once the data has been located, it promotes transparency and facilitates the use of data by humans and machines. This means that the data can be exchanged and used across different applications and systems, also in the future, for example, by using open file formats such as CSV files of quantitative data and RFT for qualitative data. This allows data to be integrated with other data either from the same research field or data from other research fields. In addition, the data need to interoperate with applications or workflows for analysis, storage, and processing. The ultimate goal of FAIR is to optimize the reuse of data. To achieve this, metadata and data should be well described so that they can be replicated and/or combined in different settings, thereby maximizing its value and impact. The principles refer to three types of entities: data or any digital object, metadata, which is information about that digital object, and infrastructure. The adoption of FAIR principles offers several benefits, including transparency. FAIR data promotes transparency by ensuring that data and its associated metadata are easily accessible and well documented. This transparency allows research findings to be scrutinized by those who wish to reproduce the results, enhancing trustworthiness of scientific research and accountability, innovation, and collaboration. By eliminating barriers to data access and use, FAIR data creates opportunities for new scientific research and collaboration. Researchers can combine and integrate diverse datasets, enabling cross-disciplinary investigations and generating new insights. Maximizing data value. FAIR data ensures that data is well described, properly documented, and accompanied by rich metadata, including provenance and licensing information. This maximizes the value of data, making them more discoverable, usable, and impactful for future research endeavors. Does FAIR data equal open data? Well, data can be fair or open, both or neither, as Hodgson pointed out in 2018. FAIR data does not have to be open. For example, data can be shared under restrictions and still be fair. In other words, data can be fair when it is accessible by a specific group of people or when it is accessible by everyone. Open data, to be open to its fullest extent, must also be fair. But note that FAIR data do not have to be open. Restricted access data may be fair, providing the metadata describing them are openly accessible. FAIR data checklist. To determine if a dataset complies to FAIR principles, one can use the FAIR data checklist to evaluate how you currently manage and share your datasets. There's also the FAIR self-assessment tool provided by ARDC. The ARDC was formed in 2018 through the merger of three existing digital research infrastructure facilities: the Australian National Data Service, National Research Collaboration Tools and Resources, and Research Data Services. They developed a FAIR self-assessment tool that enables you to assess the fairness of a dataset. Another FAIR self-assessment tool is offered by DENS. They also developed a FAIR self-assessment tool that enables you to assess the fairness of a dataset. After either of the tests, you'll even receive tips on how to enhance the fairness of your dataset. Since its beginning in early 2018, the Go FAIR community has been working towards implementation of the FAIR guiding principles. This collective effort has resulted in a 3-point framework that formulates the essential steps towards the end goal: a global internet of FAIR data and services where data are findable, accessible, interoperable, and reusable for machines. Go FAIR is a bottom-up, stakeholder-driven and self-governed initiative that aims to implement the FAIR data principles, making data findable, accessible, interoperable, and reusable. The Go FAIR initiative offers an open and inclusive ecosystem for individuals, institutions, and organizations working together through implementation networks or IONs. These implementation networks are open, inclusive, community-led and self-governed consortia working across disciplines and countries. They are committed to defining and creating specific materials and tools as elements of the Internet of Fair data and services. The INS are active in 3 activity pillars: Go Change, Go Train and Go Build. Through these 3 activity pillars, Go Fair advocates for the fair data principles. Go Change focuses on priorities, policies, and incentives for implementing FAIR. It involves a socio-cultural change, engaging relevant stakeholders at all levels necessary for the flourishing of open science. Go Train. Coordinate FAIR awareness and skills development training the required data stewards capable of designing and implementing proper data management plans, including FAIR data and services. Go Build. Coordinate FAIR technology designing and building the technical standards, best practices and infrastructure components needed to implement the FAIR data principles. To be made open and fair, data should be deposited in a data repository. A data repository is a service that exists to preserve and provide access to research data. It is a future-proofed vehicle for ensuring that data remain accessible and usable over the long term. Using a data repository is preferable to sharing data as supplementary files alongside a published article or via cloud-based file storage and sharing services such as Dropbox or the Open Science Framework, or maintaining data in private storage and sharing on request only. None of these ways of sharing data is fully fair. A data repository performs a number of specific FAIR functions. It actively preserves data for long-term viability, for example, replicating and validating data files and migrating to preservation formats. It publishes machine-readable metadata to enable online discovery. It assigns persistent, unique identifiers like DOIs to data sets and makes them sizable. IT quality controls data sets and enhances metadata, for instance by applying standard vocabularies. Although not all repositories do this, it manages online access to data so that they can be used by other people. It applies license notices to make terms of use and attribution requirements clear. Examples of data repositories include disciplinary data centers and their component databases, such as the NERC data centers and the databases of the European Bioinformatics Institute. Institutional data repositories such as the University of Reading Research Data Archive and general-purpose data sharing services like Zenodo and Figshare. We provide guidance on finding a suitable repository for your data. Some ideas to get you started to ensure your data is fair. An output management plan, or OMP, is a useful starting point for collecting or creating data, software, research materials, and intellectual property. Creating a detailed map before you begin and updating it regularly throughout the research cycle will help ensure that your outputs are as open and fair as possible at the end of the project. Some funders require grantees to share their OMP as part of their funding application or after the funding has been secured. When writing your OMP, consider what outputs will you be creating or collecting, how will these be documented, what ethical or legal requirements, if any, apply to these outputs, how will you organize, store, secure and share these outputs, what resources are required, who is responsible. Clearly and accurately describing how your data was created, how it is structured, and what it means is crucial to making your data comply with the FAIR guidelines. Someone who is not familiar with your data should be able to understand what it is about. Using only the metadata and documentation provided. Remember, it's not just humans who need to find your data set, but machines too. Good metadata is clearly associated with the data set it describes and is available in a machine-readable format, such as text or PDF. Depending on your field of study, there may already be standards in place to guide how your data and metadata should be structured, formatted and annotated. Data preservation ensures that your data will be accessible and reusable in the future. Best practices for data preservation include backing up data files, regularly storing master copies of data files in open formats, validating preserved data files regularly using more than one form of storage for data files, and appropriately securing data physically and/or on any network or computer they are held on.